And tell you a pattern is not just a symbolic expression. It's a symbolic expression along with some kind of sense making of it, along with some understanding. So f of x equals x squared is not a pattern. There's no sense making here. It's just a rule that you plug in. The difference is there's no sense making. But if you say instead area of a square whose side length is x is given by a of x equals x squared, now suddenly it is a pattern, because now there's something, some justification or some sense making. A pattern is a symbolic expression. I like giving a rule or shortcut of a process, but with some justification. I think most of the patterns that we've seen so far where we could really potentially explain them have to do with rewriting things involving exponents and powers. So for instance, if I look at a to the x times b to the x, and then I say that's equal to ab raised to the x, I would say that is a pattern. First of all, it's true. Second of all, it's a symbolic expression. And third of all, it's something that I could explain to you why it's true. So this isn't just about like memorizing rules. This is also about learning how to look for things, learning how to say, okay, here's one thing. Now, can I look for similar things? And that's a skill, and you can get better at it. But part of getting better at it is realizing that this is always going to be a process that might feel a little bit uncomfortable because you're not guaranteed to know a right answer right away. How would I explain this? And if I say b cubed, that means b times b times. If I want to claim that these two are the same thing, if I say a times b raised 3, that's a times b times a times b times a times b. Do you agree? Now I can rewrite this, because multiplication is commutative, as a times a times a times b times b times. Do you agree? And then I can rewrite that as a cubed, because this is a times a times a times. The pattern is that if I actually write this out, I can move things around. And that justifies why this rule is true. That's true for any number, and I don't want to write this out 100 times first. So I want to know I can do that. That's where the generalization, and more generally, I want to know that I can do it for any value of x. But why it's true is not just because I told you it. Why it's true is because when you look at what exponentiation actually is, repeated multiplication. And if you repeat the multiplication and move things around, that's why it works. Now, I'm really hoping that I don't just get 50 examples where somebody does a times b to the x is a to the x times b to the x. Because the whole point is, okay, now you know what we're talking about. Can you do the same thing with some other things that you might know or might learn?